Today, we are in the middle of solar cycle 25, which began in 2019 and will last approximately until 2030, going through cyclical highs and lows of solar flares, coronal mass ejections, and solar storms that will peak this or next year, making this a crucial period of time to invest in solar weather monitoring capabilities. Why it is important to study solar activity. It is no exaggeration to say that solar flares and the geomagnetic storms they can cause have a significant impact on everyone's lives. They can cause failures in the operation of satellites that are crucial for maintaining communications and navigation systems on Earth. They can also damage power grids, leading to massive blackouts, and pose radiation risks for astronauts, as well as for pilots and passengers of high-altitude flights. Active solar cycles increase the frequency and intensity of solar flares and pose danger to all technology and services affected by space weather. Such disruptions to critical infrastructure can be very costly to the economy of developed nations. Power outages caused by solar activity cost tens of billions of dollars every year. The potential global economic impact of space weather events, such as a severe geomagnetic storm, are significant and could incur losses totaling 38.4 billion euros, $41.1 billion per day. More than half of these losses are caused by indirect costs related to disruptions in supply chains. Damage from solar events can lead to logistical delays, production downtimes, increased operating costs, shortages of goods, and other problems in international trade. Solar weather forecasting also plays a crucial role in safe and effective space exploration. Without accurate forecasts and predictive analytics, space missions and the astronauts involved would be at risk of exposure to radiation and equipment malfunctions. Existing solutions and future needs. In 2024, space weather monitoring and analysis is conducted mainly through government agencies and scientific organizations. Two of the major suppliers of information are the National Oceanic and Atmospheric Administration in the United States and the European Space Agency. These organizations manage data from various sources that include satellite missions and ground-based observatories in order to create a comprehensive picture of solar activity. In addition, these organizations often use empirical forecasting models that are based on historical data. These models help identify patterns and correlations in space weather phenomena, which can then be used to predict future events. However, this information is not always accurate or up-to-date, which significantly reduces the relevancy and efficiency of the forecasting. In March 1989, when modern methods for space weather forecasting were not yet available, a powerful geomagnetic storm caused by a solar flare triggered large-scale technological disruptions and outages in the Canadian power grid. Millions of residents and businesses in the province of Quebec were without electricity for 9 hours. Another solar flare in August of the same year caused the Toronto Financial Exchange to stop for 3 hours. The lack of information about space weather can also cause significant damage to satellites and other space systems. For instance, a geomagnetic storm in February 2022 interfered with a Starlink launch, resulting in the company losing 38 out of 49 satellites. Starlink was relying on empirical models to predict atmospheric conditions, but these models had insufficient data and failed to make an accurate estimate of increased atmospheric density during a storm. This led to greater than expected atmospheric resistance and caused the satellites to malfunction.